So our job in this example is actually a little bit simpler than in the previous example. We're asked to use the shortcut equations for the resistor power to calculate the power in these two resistors. Now, obviously, staring at these, you can see that there are two resistors that are in series. We could then think about combining them in series, or we could think about using voltage division. In this case, though, we're asked to calculate the voltage across each of them first. And so that's going to encourage me to use voltage division. I'm going to go ahead and label this as V sub 15 ohms. And because there's a voltage source that's going to be driving the current clockwise, I know that it's going to be plus to minus. And then V sub 5 ohms, that's going to be plus to minus. So I can calculate V sub 15 ohms is going to be the total voltage, 10 volts, multiplied by the voltage in this resistor, 15 ohms, divided by 15 ohms plus 5 ohms. And when we multiply all that out, we get 7.5 volts. And then V sub 5 ohms is going to be 10 volts times 5 ohms multiplied or divided by 15 ohms plus 5 ohms, and that works out to be 2.5 volts. So now we've quickly found the voltage across each of them, and now we're going to use the shortcut equation to calculate the power. P sub 15 ohms is going to be V sub 15 ohms squared multiplied by 15 ohms, V squared times R. So this is going to be 7.5 volts squared times 15 ohms, which turns out to be 3.75 watts. And then the power in the 5 ohm resistor, P sub 5 ohms, is V sub 5 ohms squared times 5 ohms, which is 2.5 volts squared times 5 ohms, which works out to be 1.25 watts. Now, ordinarily we'd be done, but we were asked to then repeat the calculation by first calculating the current through each resistor. Now, to be able to do that, we're just going to combine the two resistors in series with one another. So I'll have a very simple circuit over here. So I'm going to have a voltage source and a single resistor. And that single resistor is going to be 15 plus 5 is 20 ohms. And I can calculate the current. And the voltage is 10 volts. So the current I is 10 volts divided by 20 ohms, which is 0.5 amps. And so then I can calculate P sub 15 ohms is I squared times 15 ohms, which is 0.5 amps squared times 15 ohms, which is, no surprise, 3.75 watts. And then P sub 5 ohms, just for completeness, is multiplied by 5 ohms, 0.5 amps squared times 5 ohms is going to give me 1.25 watts. One thing we find when we get to about this point in circuit analysis is that there are many different ways to solve a given problem, but all of those ways have to give the same answer. So if you find yourself with extra time, you can always try a different method, different tool, a different calculation technique, and you should always be able to find the same answers as we did in this case.